Good morning. Today we are doing lesson 6-8. You will find in the math module that there is one page that is from your math journal, but we won't get to it until a little bit later in the lesson. So let's start with our math message, and it says, you know that 2.4 times 1 equals 2.4. Will 2.4 times 1.8 be greater than or less than 2.4? How do you know? You should have realized that 2.4 times 1.8 is going to be greater than 2.4 because 1.8 is greater than 1. Remember when we did the work with fraction multiplication in Unit 5? When we multiplied a whole number by a fraction less than 1, such as 6 times 2/3, was the product greater than or less than the whole number 6? The answer is less than. Why? Because if you think of equal groups, the product is less than one group of 6. That is less than 6. When we multiplied a whole number by a fraction greater than 1, such as 6 times 3/2, was the product greater than or less than the whole number? It was greater than, because if you think of equal groups, there will be more than one group of 6. That is more than 6. You can use the same reasoning to predict sizes of products and quotients of decimals. Would 2.4 times 0.06 be greater than 2.4 or less than 2.4? How do you know? It would be less than 2.4. It is less than one group of 2.4 because 0.6 is less than one whole. Let's think about generalizing a rule about the size of a product compared to the size of its factors. If the second factor is less than 1, what do we know about the product? We know that the product will be less than the first factor. If the second factor is greater than 1, what do we know about the product? The product will be greater than the first factor. If the first factor is less than 1, what do we know about the product? The product will be less than the second factor. If the first factor is greater than 1, what do we know about the product? The product will be greater than the second factor. Predicting the size of the product is one way to make an estimate for multiplication problems. Remember in the past we made estimates for whole number multiplication problems by rounding and using close but easier numbers. Let's try to use the same similar strategies to make estimates for decimal multiplication problems. Here are a few that we will try together. So the first one is 12.8 times 185.3. So if we use the same technique, we could round the 12.8 up to 10, and then round the 185.3 to 200, which would give us an estimate of 2,000. 896 and 1/10, we could round to 900, and then 2 7/10, we could round to 3, which would give us an answer of 2,700. 4.1 would easily round to 4, and then 7/10 we could round to 1, and we all know that 4 times 1 is 4. Then finally 9/10 times 3/10, we could round the 9/10 to 1, and the 3/10 we can leave as 3/10 because we know that 1 times any other number is that number itself. So our estimate would be 3/10. So in today's lesson, we're going to use estimation to help us solve decimal multiplication and division problems. We're used to using estimates to check the reasonableness of our answers, so that's what we're going to do with these as well. So you see up at the top we have 3 problems, 110 times 2 8/10, 11 times 28 hundredths, and 11 times 2 and 8/10. The product of one of these problems is 30 and 8/10. So this is the product of one of those problems up there. See if you can figure out which product is 30 and 8/10 without calculating the problems up above. Use estimation to show your reasoning and that it makes sense. You can stop the video for just a moment while you try to do that. Okay. Now we will look at 110 times 2.8. We know that 110 is close to 100. And 2.8 is close to 3. So we know that our answer for that one is going to be somewhere around 300. That is much bigger than our estimate answer of 30 and 8/10. 11 times 28 hundredths will be less than 11 because 28 hundredths is less than 1. So if the number is going to be less than 11, we know that there's no way the answer could be 30 and 8/10. Finally, we have 11 times 2 and 8/10. 11 is close to 10, and 2.8 is close to 3, so that gives us an estimate of 30. That is very close to 30.8, so that one would have to be the correct answer. Now, if you use calculators to figure out the answer to these problems, you would have found that 110 times 2 and 8/10 equals 308. 11 times 28 hundredths equals 3 and 8 hundredths. So what do you notice about the factors in these three problems? They all have digits in the same order, but the decimal points are in different places. What do you notice about the products in these three problems? They also have the same digits, but the decimal points are in different places. So from the last page we were looking at, if you knew that the digits in each product were 3, 0, and 8, you could have used those estimates to place the decimal point in all three products. So this reasoning is also helpful for placing the decimal point in decimal quotients. Look at this problem at the top that is 82 and 6/10 divided by 7. How would you estimate a quotient for this problem? You would probably use 80 divided by 8, which we all know equals 10. Okay, now, if I told you the digits for your answer are going to be 118, where would you place the decimal point after looking at your estimate? You would place it right between the second, whoops, that wasn't what I wanted to do. You would place it right between the second one and the 8. I'm just going to write it out here to the side because it's not working. There we go. After looking at your estimate, which was 10, you would make your answer 11.8. What if the problem was 8 and 26 hundredths divided by 7? How could you use that estimate to place the decimal in 1/1/8? Well, you could round 8.26 to 7, and then 7 divided by 7 equals 1. So if I know that, then I'm going to put my decimal point right here, right after the first one, so that my answer is 1.18. Then if I had the problem 82.6 divided by 0.7, I could round 82.6 to 100, and I could round the 0.7 to 1, and we know that 100 divided by 1 equals 100. So I would guess that my answer, my decimal point, is going to go here after the 8. My answer would be 118. Let's try 4 more problems that are set up the same way. The first one is 40 5/10 divided by 3. So they've already given us that our digits are 1, 3, 5, and 0. So let's do an estimate. 40.5 could be rounded to 30. And then we're going to say divided by 3 equals 10. So the quotient should be more than 10 because 40.5 is more than 30. So that tells me that my decimal is going to go right here between the 3 and the 5. My answer will be 13 50/100. Let's look at the next one. 150 88/100 divided by 4. Let's think about it as 160 divided by 4, because once again we're rounding it to make an estimate, and we know that 160 divided by 4 equals 40. So my answer with these 3 digits, 3772, has to be close to 40. So I'm going to place my decimal point right in between the 2 sevens. So my answer would be 37.72. Now, 2 52/100 divided by 6/10. Let's round that to 2.5 divided by 0.5. That's my estimate. And we know that that is going to give us 0.5 for our estimate. Now, I know that my answer is going to be close to 0.5, so my answer is going to be, I'm going to put my decimal point just in front of the 4. So my answer would be 0.4200. Then finally, 1 54/100 divided by 7 equals, and we have the digits 2200. We know that 1.54 is less than one group of 7, so the answer must be less than 1. So if the answer is going to be less than 1, my only place for my decimal point to go is right out here in front, so that it's 22 or 0.2200. Okay, now we are going to work on the math journal sheet that I have attached in your module, so you can get that out, and we'll go over that in just a second. So I want you to take a look at this paper, and the instructions at the top, I have it in 2 different slides because the whole thing wouldn't fit on here. But the instructions say the digits provided in the answer column are correct, but they are missing the decimal point. For each problem, write a number sentence to estimate the product or the quotient. Use your estimate to place a decimal point in the digits provided. An example is done for you. So they gave us the example. Our problem is 12 2/10 times 1 9/10. So they used for the estimate 10 times 2. They rounded 12 2/10 to 10 and 1 9/10 to 2. So we know that gives us 20. So therefore, the decimal must go in between the 3 and the 1. So our answer is 23 18/100. So take a few minutes and work on this, and then when you come back, I will have the answers for you. Okay, so 17 4/10, we're going to round that to 20 times 97.5, we're going to round that to 100. So our estimate is going to be 2,000. So if these are my digits over here, that tells me that my decimal point must go over here between the 6 and the 5. So my estimate is 1,696.5. Number 2, Number 2 says 83.12 times 7.25. We're going to round that first number to 80. And we are going to round the second number to 10. So that gives us an estimate of 800. So looking over here at our digits, that tells us that the decimal point must go in between the 2 and the 6, right there in the middle. So our answer is 602 and 62 hundredths. For number 3, we're going to round 36 hundredths to 1/2. We can just use a fraction there. And then we're going to round 325 and 5/10 to 300. So we know that half of 300 is 150. So therefore my decimal point is going to go right in between the 7 and the 1 for an answer of 117.18. Okay, so I just realized that we cut out 4, 5, and 6, so I'm going to just do those at the top here for you. Number 4 should be, we're going to round 4.85 to 5, and we're going to round 0.6 to 1, which gives us an answer for our estimate of 5. So your decimal should be 2.91, because that's going to be the closest way to do it with an estimate of 5. Number 5, we're going to round 1.8 to 2, and we're going to round 27.3 to 30, which gives us an estimate of 60. So our digits are 4, 9, we're going to put our decimal point right there, 1, 4. So that's how we would write those digits with an estimate of 60. Our answer is going to be 49.14. Then number 6, we would round 95.76 to 100. And we're dividing now, so we're going to divide by 7.6, we're going to divide by 10, which gives us an estimate of 10. So your answer is going to be 12, put your decimal point right there, 0.6. Okay, number 7, 515 and 87 hundredths. We're going to round that to 490. Remember, we want to pick out numbers that are going to be easy to work with. We're going to round 65.3 to 70, which gives us an answer of 7 for our estimate. So therefore, the decimal is going to go right in between the 7 and the 9 for 7.9. Number 8, we're going to round 2.76 to 3, divided by 3.68. We're going to round that to 4, and that gives us an answer of 3/4 if we think of it as a fraction, which means our answer has to be, the decimal point's going to go right there between the 0 and the 7 for 75 hundredths, because 75 hundredths is the same as 3/4. Number 9, we're going to round 101.8 to 100, divided by 0.8, we're going to round to 1, so our estimate is 100. So that means our decimal has to go between the 7 and the second 2 right there. And then for our last one, 1,390 and 72 hundredths, we're going to round that to 1,400, divided by, we're going to round 21 and 73 hundredths to 20, which gives us an estimate of 70. So we know then that our decimal point has to go after the 4 and makes our estimate 64. Okay, go ahead and try to do those bottom 2 problems where it says try this at the bottom of the page, and then you have math boxes 6-8 and HomeLink 6-8 to do, and then you will be finished with this lesson. Thanks, and have a great day.